morning, sir. I am J. Alagraj. First time is in chemistry. I am discuss about the topic chain reactions, decomposition of nitrogen pentoxide and decomposition of decomposition of nitrogen pentoxide. Introductions. The kinetic of the reaction is the first investigated by Daniel and Johnson, who believed that they had discovered the first two unimolecular gas reactions. Another point, the rate was controlled by breakdown of nitrogen pentoxide in following step. The following mechanisms are: decomposition of nitrogen pentoxide is 2N2O5 gives 2N2O4 plus O2. Further mechanisms was classified by Daniels. N2O5 gives 2N2O5 plus O2. This is a slow reaction. N2O3 gives NO plus NO2. This is a fast reaction. Another fast reaction is NO plus N2O5 gives 3NO2. Then Arc proposed the decomposition of nitrogen pentoxide as the following mechanisms. The mechanisms was in first order kinetics, N2O5 gives NO2, then NO2 plus NO3, that intermediate gives N2O5, then NO2 plus NO3 gives NO2 plus O2 plus NO. Then another reaction is NO plus N2O5 gives 3NO2. The intermediates NO3 and NOs are present in smaller amount than nitrogen pentoxide, and the steady state applied to steady state hypothesis for NO3 molecule and NO molecule. For NO3, K1 N2O5 minus of K minus 1 plus K2 N2O5 concentration of NO3 equal to 0. Then NO K2 NO2 NO3 minus K3 concentration of NO concentration of N2O5 equal to 0. The rate of consumption of nitrogen pentoxide, that is minus of D concentrations of N2O5 divided by dt equal to K1 N2O5 minus K minus 1 N2O5 NO3 concentrations plus K3 concentration of NO and concentration of N2O5. The above reactions was simplified as minus of the total rate consumption of nitrogen pentoxide reaction is in eliminations of NO2 and NO3, that gives minus D of N2O5 gives dt equal to K1 concentration of N2O5 plus K1 K2 minus K1 concentration of N2O5 divided by K minus 1 plus K2. The total rate consumption of N2O5 is minus D of N2O5 divided by dt equal to 2K1 K2 by K minus 1 concentration of N2O5. This is the nitrogen pentoxide is the first order reactions. Next we discuss about decompositions of ozone. Ozone decomposes in heat or temperature to give oxygen and usually occur partially on surface of the vessels and partially occurs on the gas phase. Decomposition of ozone in presence of excess of oxygen, and the reaction is to be second order in ozone. The reactions are O3 gives in equilibrium O2 plus O. The another reaction is O plus O3 gives 2O2. The decomposition of molecule as simple ozones, it will be second order except at extremely high pressures. The following mechanisms are O3 plus M equilibrium O2 plus O plus M. O plus O3 gives 2NO2, 2O2. For applying the steady state approximations of oxygen atom, that is K1 O3 concentrations of M minus of K minus 1 concentrations of O2 concentration of O concentrations of M minus K2O O3 equal to 0. This is the first equation. Then we calculate the concentration of ozone equal to K1 concentrations of O3 concentrations of M divided by K minus 1 concentrations of O2 concentrations of M plus K2 concentration of O3. That is the second equation. Then we calculate the rate of consumption of decomposition of ozones minus D concentration of O3 divided by KT equal to K1 concentration of O3 concentrations of M minus of K minus 1 concentration of O2 concentrations of O concentrations of M plus K2 concentrations of O, concentration of O3. This is the third equation. And so overall reaction since the rate of consumption of decomposition of ozone is minus d of concentration of O3 divided by dt equal to 2 K1 K2 concentration of O3 square concentrations of M divided by K minus 1 concentrations of O2 concentrations of M plus K3 concentrations of O3. Then in photochemical reactions, in ozone, in light gives O2 star plus O star. The reaction 2nd and 3 are chain propagating steps, and 4 and 5, 6 equations are chain ending steps. In invisible light, the oxygen atoms are not produced in a singular D state, but less energy in triplet P state. These atoms have insufficient energy to produce oxygen molecules, having enough energy to regenerate oxygen atoms. Energy chains are not involved. This is the decomposition of ozone. This is a second order reactions. Thank you.